When a digital scale sits empty, slight drafts or vibrations can cause the readout to flicker. To prevent this, manufacturers build a zero tracking feature, a digital lock that automatically corrects these tiny fluctuations to hold a perfect zero. But if that automatic correction is too aggressive, it hides legitimate product weight. This creates measurement errors that can lead to consumers being undercharged or, in a laboratory setting, invalidate a legal calibration. Today, we are going to test those exact limits. You will learn how to verify that a scale's zero tracking is within legal boundaries and how to use a bypass load to reveal the scale's true, uncorrected performance. Before starting, ensure the scale has been powered on and stabilized for at least 30 minutes. You will also need a specific set of certified test weights, one 10E weight, three 0.3E weights, and one 0.7E weight. Proving the tracking mechanism operates within legal limits and knowing how to bypass it is a requirement for ensuring a scale meets the strict standards of legal metrology. Let's begin the physical setup. As mentioned, your scale must be powered on and allowed to sit for a minimum of 30 minutes to ensure the internal electronics reach thermal stability. The math for all our tests is based on E, the verification scale interval. This is the division of weight used to classify the scale and determine its accuracy class. For this simulation, our E value is 10 grams. However, to see the fractional weights, we will use the scale's high-resolution mode, where the actual scale interval, or D, is set to 1 gram, seeing increments 10 times smaller than the standard display. With the high-resolution mode active, look at your display. Ensure the scale reads a perfectly stable absolute zero before any test weights touch the pan. Establishing this precise zero is mandatory. If the starting baseline is drifting, any measurements we take to verify the tracking rate will be mathematically flawed and legally invalid. Step 1 is the rate test. International regulations state that a zero tracking device cannot correct more than half an E per second. We will now determine if the tracking is operating within that limit. To start, place a 10E load, which is 100 grams, directly onto the center of the pan. This intentional load pushes the scale into a range where zero tracking is supposed to stop. Now, gently add your first 0.3E weight, that's 3 grams, and wait exactly 2 seconds. Add the second 3-gram weight and wait another 2 seconds. Finally, place the third 3-gram weight onto the pan. A significant jump in the readout shows that we have successfully bypassed the tracking mechanism. This confirms that the scale is now showing us the true weight on the pan without correcting for it. If the display remains unchanged after adding these weights, it indicates the zero tracking is still active. Because we added 3 grams over 6 seconds, this result shows the scale is correcting at a rate of roughly 0.15 E per second, which is well within the legal limit of 0.5. Once you see that jump in the readout, you have confirmed the bypass is active. The scale is now a dumb instrument, ready to provide uncorrected data for the rest of your calibration. Next is the drop test. This checks the single operation limit, or the maximum amount of weight the scale will automatically erase if it's removed all at once. The rule for this test is that the scale must never automatically re-zero a remaining load that is greater than 0.6 E. Clear the pan and re-zero the scale. Using your high-resolution mode, place your 100-gram weight and a 0.7 E weight, which is 7 grams, on the pan. The display should read exactly 107 grams. Now, quickly but gently lift the 100-gram weight off, leaving only the 7-gram weight behind. Step back and observe the 7-gram readout for exactly 10 seconds. If the display holds steady at 7 grams, the scale tosses. Because 7 grams is greater than 0.6 E, the scale is legally required to recognize it as a real load rather than tracking it back to zero. If the readout snaps to zero during those 10 seconds, the tracking is too aggressive. It has just erased a load that is legally significant. Passing this test ensures the scale can distinguish between an empty pan and a small product load, guaranteeing that low-weight measurements are actually being recorded. You have now successfully verified the automated zero tracking limits of your weighing instrument. These two markers, a tracking rate below 0.5 E per second and a single drop limit under 0.6 E, are the benchmarks for a legally compliant zero tracking device. You also now have the 10E bypass technique in your toolkit, allowing you to disable these automated corrections to see the scale's raw performance. With the tracking limits verified and the bypass active, your scale is now a trusted baseline. You are ready to move to the next vital stage of the process, determining the true 0-point error.